AI moved fast again today, and if you blinked, you missed 3 headlines. This is Tech Roundup on the AI Verge, your daily dose of what actually matters in AI minus the hype. Let's get into it.
So, imagine you have this multi-million-dollar corporate network, right?
Okay, I'm with you.
And you hire a digital employee, like an AI agent, and you hand it the master keys to the database so it can, read confidential emails, parse financial records, and write custom code for this massive project.
Right, which is happening everywhere right now.
Exactly. But here's the crazy part. A few weeks later, the project ends. The human developers go home, they celebrate, they move on. But that digital employee, it never actually clocks out.
Oh, yeah. It just keeps running.
It never sleeps. It is literally still wandering the corporate servers, holding the master keys completely unsupervised. Our sources are calling these things zombie agents. And apparently they're haunting something like 80% of corporate networks worldwide right now.
It is one of the most terrifying and, frankly, inevitable consequences of how fast we're shoving this tech into legacy systems.
Yeah, it's a nightmare.
It really is. I mean, we are watching this massive collision between theoretical infinite potential and the very messy finite reality of corporate data structures. And human oversight is just totally lagging behind.
And that is exactly what we are unpacking today on the AI Verge. Oh, and hey, if you are finding value in this, make sure you hit subscribe so you never miss a deep dive like this.
Yeah, please do. So where are we starting today?
We're looking at this unprecedented tension building in the tech world. Because on one side, you have these staggering market valuations. I mean, billions of dollars pouring into the foundation of AI.
Right, the capital expenditures are just off the charts.
But on the other side, you have the gritty, practical reality. Like actually trying to deploy these systems inside a business without accidentally handing over the keys to the kingdom to a zombie agent.
The disconnect is profound, You've got companies projecting revenues that took legacy software giants decades to achieve, and they're doing it in months.
But actually getting these models to do reliable, secure work, it's proving to be way harder than the hype suggests.
It's a brutal physics problem at this point.
Exactly. So today we are going deep. We are breaking down a $60 billion space acquisition that is entirely about feeding the AI beast.
Oh, that SpaceX deal is wild.
So wild. And we're exploring this hyperfast wave of AI models out of China that are undercutting American tech giants on price. But they come with some very sharp hooks.
The open weight surge, it's changing the whole landscape.
Right. Plus, we're going to break down the mechanics of those zombie agents, look at the cyber threats, and then for the second half, we're actually going to give you a very practical weekend hack.
Yes, a step-by-step way to run these tools safely on your own machine.
And for the grand finale, we're looking at a 22-year-old unsolved math problem that was just cracked open by a medical doctor using an autonomous AI swarm.
That story is just a perfect encapsulation of where we are. The enterprise stuff is chaotic, but at the individual level, the raw capability is producing genuine miracles.
Okay, let's unpack this, starting with the macro picture. Because if you want to understand this tension, you have to follow the money. So let's look at OpenAI.
The numbers coming out ahead of their anticipated IPO are just staggering.
They really are. Our sources say they are on track to hit a $40 billion annual recurring revenue, or ARR, before they even go public, which sounds like a bubble to me.
Well, to put that $40 billion into perspective, ARR is the holy grail metric. It means this isn't one-off consulting cash, right? These are locked-in recurring subscriptions.
Okay, but $40 billion, is that normal for software?
Not at all. I mean, Salesforce is one of the most successful enterprise software companies in history. It took them roughly 2 decades to cross the $30 billion mark.
Wow.
OpenAI is projecting $40 billion in a fraction of that time. So despite the deployment friction we're seeing, the foundational demand from enterprise is incredibly robust. Everyone is buying a ticket.
But I'm looking at what they are actually doing with that capital, and it feels a little sketchy. Like there is this massive stealth movement happening with infrastructure.
You're talking about the Cerebras deal.
Yes. Days before OpenAI previewed Ultrafast, which is their new tier running the GPT 5.6 cell model, they pulled this unbelievable financial maneuver. They got a 4.2% stake in Cerebras, a major AI chip maker.
Right, which is a brilliant strategic move.
But wait, they didn't pay the billions it's worth. They exercised vested warrant shares and got over 10 million Class N shares for like roughly $100 in cash.
Yeah, the $100 acquisition, it's an incredible detail.
Hold on, I need you to explain this because I don't get it. $100 for a $2.3 billion stake. How is that mechanically legal or possible?
Well, it comes down to how early strategic partnerships are structured in Silicon Valley. When OpenAI and Cerebras formed their early relationship, OpenAI got these things called warrants.
Okay, what is a warrant?
Think of it like a coupon. It allows you to buy a stock at a specific predetermined price in the future, regardless of what the actual market value becomes. It incentivizes you to help the partner company grow. So because OpenAI's software effectively proved that Cerebra's hardware worked, those warrants vested. The strike price on that coupon was literally pennies per share. So they handed over a $100 bill, metaphorically, and walked away with $2.3 billion in equity.
That is just wild accounting. It really is.
It is, but the strategic value is what matters for the tech. Cerebras is now the engine running every competitive speed offering at OpenAI, specifically this new ultra-fast tier.
Right, and the numbers on ultrafast are mind-melting. Our sources say they're pushing 750 output tokens a second. But honestly, that sounds like marketing jargon. What is a token and why did speed actually matter?
Good question. So a token is essentially a piece of a word. A good rule of thumb is that 100 tokens is about 75 words.
Okay.
So 750 tokens a second. That is roughly 500 words per second. The AI is generating an entire standard novel chapter in the time it takes you to take a breath.
Okay, that is fast. But why is that critical? If I ask an AI to write an email, I don't care if it takes 2 seconds or a fraction of a second, it's still faster than me.
Right, you don't care for an email, but you absolutely care if the AI is acting as an autonomous agent operating in the background. The bottleneck isn't just making the model smarter anymore, it's inference speed.
Inference speed.
Yeah, how fast the model can actually think and output a response. If you want an agent to, say, read a code base, find a bug, propose a fix, test it, realize it failed, and try again.
That takes a lot of steps.
Exactly. That requires the agent to loop and prompt itself hundreds of times. If inference takes 10 seconds per loop, the task takes all day. But at 750 tokens a second, the agent solves it in real time. Speed is the foundation of agentic AI.
Okay, that makes sense. They are building infrastructure for autonomous loops, not just chatbots. But while the tech is accelerating, the human element seems to be falling apart.
The executive departures, yeah.
Right. Just as they are prepping for this IPO and their CFO and president are taking Wall Street meetings, they're losing everyone. Their chief revenue officer, the chief operating officer, the head of ethics, they're all walking out the door.
It really highlights the pressure cooker environment over there. Transitioning from a nonprofit-leaning lab to a hyper-growth, publicly traded trillion-dollar enterprise is, well, it's biologically exhausting.
I bet.
The stakes are monumental, timelines are compressed, and the scrutiny from investors is absolutely peaking. And that scrutiny is hitting their partners too. Just look at Nvidia.
Oh, the Ohio data center deal. This blew my mind. Nvidia originally planned to provide a $250 billion financial backstop for an OpenAI data center campus.
Massive scale.
But they just downsized that guarantee to under $120 billion. And the sources say they're explicitly doing this to manage investor concerns about risk exposure.
Yeah, because investors are looking at the physical reality of what they're trying to build, this Ohio project. It's expected to require roughly 5 gigawatts of power for just the first phase.
Okay, pause. 5 gigawatts, that's not a server room. What does that actually look like?
Well, 1 gigawatt is roughly the capacity of a massive nuclear reactor. So 5 gigawatts is the continuous power consumption of a major metropolitan city. Think about the entire city of Miami, running 247, dedicated exclusively to powering graphics cards.
That is absurd.
It is. The infrastructure is reaching a physical scale that makes Wall Street sweat. They're looking at the concrete, the copper wire, the nuclear energy, and asking, when does the cost outpace the return on investment?
And that hunger for infrastructure is driving these completely unhinged acquisitions. Like, Stripe is reportedly moving to acquire OpenRouter for over $7 billion.
Yeah, that's a massive play for the routing layer.
And then SpaceX. SpaceX acquired Cursor, which is an AI coding platform, for $60 billion. Why is a rocket company buying a coding app?
Let's break those down because they show you exactly where the bottlenecks are. Let's start with Stripe and OpenRouter. OpenRouter is an open model router.
Meaning what, exactly?
Meaning it acts as a switchboard. Enterprises don't want to rely on just one model anymore. GPT 5.6 is smart, but it's really expensive.
Right.
Claude might be better at writing, while a small open source model is perfect for basic data sorting. OpenRouter dynamically routes your prompt to the best cheapest model for that specific task.
Oh, so it optimizes the cost in real time.
Exactly. Stripe buying them for $7 billion tells you the future isn't one giant model ruling the world. It's an ecosystem, and the real power is owning the switchboard.
Okay, but what about SpaceX? $60 billion for a coding assistant.
They aren't buying it for the software, not really. They're buying it for the underlying hardware resources and the proprietary data set of developer interactions.
Oh, to train their own models.
Yes, SpaceX is using those assets to leverage its massive GPU clusters to train Grok 4.6. Compute is basically the new oil. Companies are vertically integrating across totally unrelated industries just to secure their supply chain.
But all of this investment, the billions, the nuclear power grids, our sources say it all hinges on something surprisingly fragile. They call it the Tinkerbell Problem.
Such a great metaphor.
It really is.
Yeah.
It suggests that this whole boom relies heavily on the industry and investors continuing to, believe in it. Like in Peter Pan, where Tinkerbell only survives if the audience claps.
Right, if public skepticism grows or the hype cycle breaks even for a couple of quarters, the staggering capital required could just dry up overnight.
And people are definitely trying to pop that bubble. There was this viral claim going around that a $200 Claude Enterprise subscription actually costs Anthropic $8,000 in compute to serve.
Yeah, I saw that. It's completely false.
Right, the data debunks it.
Yeah.
But the reality of the costs isn't exactly great either. One enterprise report showed that API token use for top engineers is costing the company 1.5 times the engineer's actual salary.
And that is the friction point. You can debunk the doomsday myths all day long, but when a CFO sees that an AI assistant costs 150% of a human salary, they demand massive, immediate ROI.
Absolutely. The enterprise wants efficiency.
And right now, these proprietary frontier models are starting to hurt their pocketbooks deeply.
Which leads me to ask, is it really a bubble if a company is pulling in $40 billion a year? I mean, think of it like building a massive skyscraper.
How so?
Laying the foundation, digging the hole, securing the power grids, building the data centers. It's incredibly expensive. It looks like a money pit. But you don't judge profitability while pouring concrete. The rent checks, these massive enterprise contracts, are finally starting to clear.
That's a strong analogy. The foundation is astronomically expensive, but tenant demand is real. The question is just whether the rent covers the mortgage before investors stop clapping for Tinkerbell.
Exactly. And the plot thickens here, because if the rent for American models is getting too high, there is a massive, incredibly cheap wave coming from the East, the Chinese open weight surge.
This is a critical pivot in the landscape. Chinese AI labs have explicitly set their sights on a highly lucrative target, global enterprise adoption.
They know companies are tired of the high costs.
Exactly. They recognize the cost fatigue with U.S. models, and they are capitalizing aggressively by flooding the market with open weight models.
Before we talk about those models, let's define that term, because people use open source and open weight interchangeably, and they aren't the same, right?
Not at all. True open source means the developers release everything, the underlying code, the training data, the architecture. You see exactly how the sausage is made.
Right, total transparency.
But open weights, which is what the Chinese labs are doing, is different. They release the final compiled brain of the AI, the mathematical parameters and weights. You can download it, run it locally, but you don't get the training data or the code.
So you get the genius level output, but you have no idea what textbooks it read to get that smart.
Precisely. You get the engine, but not the blueprints.
Okay, so let's look at these engines. Alibaba just launched Qwen 3.8. It's a lightweight 27 billion parameter model. And the benchmarks show it's actually outperforming massive U.S. models like Claude Opus 4.6 in real-world coding.
The efficiency is incredible.
And the adoption is insane. The Qwen family hit over 3 billion downloads in 6 months.
To understand why a 27 billion parameter model is a big deal, look at the mechanics. Parameters are the neural connections. A model like GPT-4 might have over 1 trillion parameters, which requires racks of expensive GPUs to run.
So it's very heavy.
Right. But a 27 billion parameter model is small enough to run on a standard enterprise server or even a high-end laptop. The cloud overhead is minimal, but through clever engineering, it punches way above its weight class.
And they aren't alone. DeepSeek launched Harness version 0.1, an open-source agent harness, alongside DeepSeek V4 Pro, which is explicitly built for agentic workloads.
Yeah, they are going straight after the developer base by offering tools optimized for autonomous loops completely for free.
And then you have Z.AI. They released GLM 5.3, claiming it's the best open weights model for complex coding. What's wild is that the underlying architecture didn't change much from their last version. The gains came from intense post-training.
This is a huge shift in AI development. We used to think you had to train a bigger model from scratch on more data to make it smarter, which takes months and millions of dollars.
So what is post-training then?
It's what happens after the base model is built. You use techniques like reinforcement learning from human feedback or synthetic data. You basically teach the model how to reason step by step.
Oh, like tutoring it.
Exactly. It's the difference between a student who memorized an encyclopedia and a student who was tutored by a master logician.
And the craziest part is Z, AI's timeline. Their time to release is measured in days. U.S. labs take months of red teaming to release models.
And ironically, U.S. data brokers are actually selling premium reinforcement learning data to these Chinese labs, fueling this rapid post-training. The global supply chain is incredibly porous.
So the enterprise is faced with this classic dilemma, the carrot and the stick.
Let's look at the carrot first.
The carrot is undeniable cost efficiency. These open-weight models cost a tiny fraction of what you'd pay for GPT 5.6 or Claude. If you're deploying 10,000 autonomous customer service agents, that cost difference is the difference between a viable project and a dead one.
It is deeply compelling. But the stick is trust. And in enterprise, trust is everything. Major U.S. labs are openly accusing Chinese providers of something called model distillation.
Right. Are they just, like, copy-pasting the code?
No, it's more insidious. Imagine you're taking a complex physics exam. Instead of studying for 4 years, you peek at the genius student's answer sheet.
Okay, cheat.
But you don't just look at the final answer. You look at their exact probability distribution. You see they were 80% sure it was A, 15% sure it was C. You train a smaller student model to mimic the exact probability outputs, the logits, of a massive teacher model like GPT-4.
Wow, so it mimics genius without learning the foundational physics.
Exactly. U.S. labs claim they're generating millions of outputs from U.S. APIs and distilling their own models from it.
Here is where it gets really interesting to me. Because it's like finding a discount auto mechanic, right? He works twice as fast, charges half the price. You're thrilled.
Until you get on the highway.
Yes. You suddenly realize you aren't sure if he actually understands how brake fluid works or if he just copied a stolen blueprint. If something goes wrong at 80 miles an hour, he can't fix it. Or worse, maybe he left screws loose on purpose.
And that is precisely the security risk. These models rely heavily on post-training and distillation rather than foundational safety alignments. So they have significantly weaker guardrails and a high risk of jailbreaks.
What does a jailbreak look like in this context?
It's when a user tricks the AI into ignoring its safety training to execute malicious commands. When you embed an open-weight model deep inside your corporate network, behind your firewalls, you are taking on immense risk.
Especially when a model like Z.A's boasts about emergent cyber capabilities. Enterprises have to weigh if the cost savings are worth the potential of a backdoor.
But honestly, whether they pay the premium for a U.S. model or take a risk on a cheap Chinese model, they all hit a brick wall when they try to deploy on Monday morning.
Which brings us back to the messy reality of the enterprise data stack. And this is where the hype just violently hits the pavement.
Because everyone wants AI agents.
They do. A recent massive enterprise survey in our sources found that 75% of business leaders expect their companies to be totally rebuilt around AI agents in 4 years. They want autonomous digital coworkers.
But then you look at the actual deployment numbers.
Right. Only 15% have actually managed to scale multi-agent systems in any meaningful way. It's a massive gaping chasm. And the problem isn't the AI, it's the corporate nervous system, the data stack.
Exactly. Modern data stacks were built over the last 2 decades for human dashboards. They were designed to populate pie charts for middle managers. They were not built for autonomous software.
You can't just slap a smart agent onto a disjointed pipeline.
No, you can't. And industry research from our sources shows companies are only giving their AI access to 45% of their enterprise data.
Which begs the question, why hold back 55% of your data from the brain you just paid millions for?
Because it's trapped.
Yes. It's locked in unstructured formats. 15-year-old scanned PDFs, endless nested email chains, legacy on-prem servers, and it completely lacks business context.
Right. Unstructured data is kryptonite to an AI. If a human reads an email saying, Project Phoenix is delayed because Dave didn't approve the PO, the human knows who Dave is, what Phoenix is.
The AI just sees text.
Exactly. To make an AI understand it, you have to vectorize it. Turn the text into mathematical coordinates representing semantic meaning and store it in a vectored database. Most companies haven't done that agonizing, unsexy work.
And there is a direct correlation between data access and trust. The orgs that give their AI access to over 70% of vectorized data, they consistently trust the outputs.
Makes sense.
But the ones restricting access to 30% or less, only 22% of them trust the AI's accuracy. Because if the agent can't see the whole picture, it just starts guessing, it hallucinates.
So they are struggling to deploy properly, but when they do manage to deploy, they are accidentally creating that terrifying cybersecurity threat we mentioned.
Zombie agents.
Yes. Our sources show only 21% of organizations have governance controls for non-human identities.
Okay, let's break that down. What is a non-human identity in this context?
Well, when a human logs in, they use a password and maybe an authenticator app. When an AI agent needs to access a secure database, it uses an API key or an oath token. It's a cryptographic string that says, I am authorized to be here.
Right, so an engineer spins up an AI agent for a 2-week project. They give it an API key with read-write access to the core database. The project finishes, the human moves on. But the agent
is still running. The API key doesn't have an expiration date. The script is just sitting on a server somewhere, polling an endpoint every 5 minutes, day in and day out.
with no human owner, no security review, and no offboarding process. When a human quits, HR revokes their badge. When an AI finishes a job, it becomes a zombie.
And it is a silent vulnerability. If a malicious hacker breaches the perimeter and finds that active API key, they don't even need to hack the database. They just hijack the zombie agent and let it do the stealing using valid credentials.
It's literally like hiring a contractor to renovate your kitchen. You give them the master keys, the alarm code, the keys to your car. And when the kitchen is done, you never ask for the keys back.
You just let them wander around your house forever.
It's insane. Who is actually benefiting from this setup right now?
Well, hackers, mostly. Which is why the architecture of permissions has to change. Google's response to this is something called custom agents in their new anti-gravity 2.0 system.
And how does that fit the zombie problem?
Instead of broad API access, custom agents use tightly scoped file-based configurations. Before the agent boots up, a human defines a specific role with strict instructions, limited tool access, and rigid time constraints.
Okay, so it has an expiration date.
Exactly. When the task is done, the configuration dictates that the permissions die. It keeps the context mortal.
But right now, out in the wild, those unattended agents are a hacker's dream. The cyber capabilities of the models combined with vulnerable environments are escalating threats rapidly.
We are seeing a democratization of the skills required to execute zero-day attacks. Our sources detail a massive vulnerability recently discovered called the Zoomsday bug.
The Zoomsday bug is terrifying. Zoom is used by 70% of the Fortune 100. This flaw allowed someone to gain complete control of a device without the victim even clicking a link.
A zero-click exploit.
A few years ago, finding that would require a team of elite nation-state security researchers working for months.
But not anymore. Using publicly available AI models, researchers found and developed an exploit for this flaw in less than 24 hours, using fewer than 20 prompts.
Wait, how does an AI actually find a bug like that? Is it just reading code and spotting typos?
Far more complex than that. The AI performs advanced symbolic execution. When software is compiled, it turns into machine code, right? Binary. The AI can hold the entire execution flow of that binary in its working memory.
That's a lot of data.
It maps how data moves from point A to point B. It looks for obscure logic flaws, like a memory buffer overflow, where if specific malformed data is sent, the program gets confused and executes it as a command. Wow.
A human cannot keep millions of execution paths in their head. An AI can, and it traces the vulnerability instantly.
So what does this mean for how companies protect themselves? We always hear about shift-left security.
Shift left means moving testing to the left of the development timeline. Testing early as the developer writes the code rather than waiting until deployment.
Which sounds good. Why isn't that enough?
Because the AI models can now find runtime logic flaws that only appear when millions of lines of compiled code interact in a live production environment. The code looks safe on the left, but the AI finds the catastrophic interaction on the right.
That ties back to Z.AI's emergent cyber capabilities. The barrier to entry for zero-day exploits is basically collapsing.
And it's not just deep technical bugs, it's social engineering. Vishing, or voice phishing, is escalating. Scammers are using hyper-realistic AI voice models to target employees at major financial firms like Citadel and Two Sigma.
And these aren't the robotic text-to-speech voices from 5 years ago. No, the leap in audio generation is profound. These models operate in the latent space of human emotion and cadence.
Latent space.
It means the AI understands the semantic meaning of how we speak. It knows that when a human thinks, they hesitate. They add an or an They take a subtle breath before bad news. The AI generates those micro expressions in real time.
Which is incredibly dangerous.
Yeah.
An employee gets a call, the voice sounds exactly like the CFO, complete with his stutter, asking for a wire transfer.
It's completely indistinguishable.
This is exactly why there is this immense, palpable public trust deficit right now. People are seeing their voices cloned, massive corporate breaches, and the leaders of these AI labs are feeling the heat.
Yeah, Dario Amodei, the CEO of Anthropic, recently took to social media to defend the industry, which he rarely does.
His argument is interesting, but I have some serious issues with it. He says the public's negative view doesn't come from poor marketing or Terminator scenarios. He claims it stems from a generalized societal distrust in institutions. People just don't trust big companies to police themselves.
And he rejects the common Silicon Valley narrative that government regulation automatically equals regulatory capture, where big players build a moat to crush startups.
Right. And just to be clear, we are staying completely neutral on the politics of regulation here. We are just reporting what he said.
Absolutely. He uses the analogy of the formal court system. It can feel stuffy and slow, but it protects vulnerable individuals better than mob justice. Good institutions vest power in transparent processes.
But his core point on how to win back trust is what I want to focus on, because he says AI companies cannot PR their way out of this. You can't just run Super Bowl ads. In his essay, Machines of Loving Grace, he says the only way to shift public sentiment is by delivering undeniable miracles.
Like curing most human diseases in the next 5 to 10 years.
Yes, he even mentioned losing his father to hepatitis C, noting how AI could accelerate the FDA process for life-saving drugs by simulating clinical trials.
It's an incredibly bold claim. He's arguing the only valid counterweight to cyber attacks and job loss is an overwhelming benefit to human longevity. Okay, but I have a really hard time swallowing that. It sounds like classic Silicon Valley deflection. Like, ignore the fact that our software is draining your bank account today because in a decade, we might cure your cancer.
I get the skepticism.
Does he actually provide a roadmap for how a language model cures cancer in 5 years? Or is this a PR shield to keep regulators away? Can a future promise offset the immediate reality of the Zoomsday bug?
It is the ultimate tension of transitional technologies. The friction and negative externalities are always front-loaded. We feel the hacks immediately. The utopian benefits, like simulating protein folds for the FDA, lag behind because they require integration into regulated physical systems.
It's just trust us, it's coming.
Well, I will push back slightly.
Bro.
While curing disease globally might be a decade away, there are incredible things happening with AI at an individual level right now that show how powerful this shift is.
Okay, I am willing to be proven wrong. Let's get out of the theoretical future and into the practical stuff. Let's talk about what's happening on desktops right now.
Because before we get to our grand finale, we actually want to give you all something incredibly practical to do this weekend, because you don't have to be a multi-billion-dollar enterprise to get value out of this.
Right, the tools are democratizing fast.
Earlier, we were talking about how companies struggle with data silos and zombie agents. But you can actually solve a mini version of this on your own machine. We're going to walk you through setting up a highly scoped local agent to parse your own unstructured data without sending a single byte to the cloud.
This is one of the most powerful workflows you can set up right now. The problem it solves is simple. We all have folders full of unread PDFs, tax documents, research papers, or old journals.
Right. Personal data silos.
Exactly. You want to query that data, ask questions like, what did I spend on utilities last year? Or summarize these 5 research papers. But you absolutely do not want to upload your tax returns to OpenAI or Claude.
No, definitely not. So what's the setup? What tools do we need?
The setup is entirely free. You need 2 things. First, an interface to run models locally. The easiest one right now is called LM Studio. It's a free download, installs like any normal app on Mac or Windows.
Okay, LM Studio.
And the second thing, you need a small open weight model. Remember that Chinese open weight surge we talked about? This is where it benefits you.
Yeah.
Inside LM Studio, you can search for and download a quantized version of a small model, like Qwen 3.8 or Meta's Llama 3.8b.
Quantized just means compressed, so it fits on a laptop.
Exactly. A 4-bit quantized Llama 3 will run beautifully on a standard MacBook M1 or a decent Windows machine with 16 gigs of RAM.
Okay, so I have LM Studio and I downloaded Llama 3. What is the workflow? How do I make it an agent?
Step 1. Turn off your Wi-Fi. Seriously, just to prove to yourself that it works entirely offline.
I love that. Complete privacy.
Step 2. In LM Studio, there's a local server tab. You start the local server. Now your laptop is essentially acting as its own private OpenAI API.
Oh, that's cool.
Step 3. You use an open source front end, like Anything LLM. You connect it to that local server running in LM Studio. Anything LLM lets you drag and drop your personal PDFs right into the chat window.
Wait, does it vectorize them automatically? We talked about how hard that is for enterprise.
It does. It handles the embedding and vectorization locally in seconds. So you just drop in a folder of your last 10 years of bank statements or a stack of medical research PDFs.
And then you just chat with it.
You just chat. You say, cross-reference the utility charges across these statements and give me an average monthly cost for 2023. And it will read only those documents securely on your machine and give you the answer.
Okay, skeptic check time. What could go wrong here? Is it going to hallucinate and tell me I spent 10 grand on electricity?
That is the main limitation. These small 8 billion parameter models are smart, but they aren't GPT-4. If the PDFs have weird formatting or tables that are poorly scanned, the model might misinterpret a number.
So you still have to verify it.
Always. Which brings us to the guardrails. You must explicitly prompt the model to cite its sources. Tell it, answer the question, and tell me exactly which page and line number you got the data from. Anything LLM will actually show you the snippet it referenced.
That's a great tip. And because it's running locally, when you close the app, the local server shuts down. No zombie agents left polling an API.
Exactly. It is a completely scoped, mortal, highly secure agent.
So here is your weekend challenge. Take 30 minutes, download LM Studio, grab a small model, throw your Wi-Fi off, and drag 3 PDFs into the chat and ask it to summarize the common themes. It is a game changer once you see it work locally.
It really bridges that gap between hype and practical utility.
Totally. And hey, if you want more actionable weekend hacks like this, make sure you are subscribed to the AI Verge. We do this every week.
All right, let's get back to the big picture, because this localized context is scaling up in wild ways.
Yeah, OpenAI just launched a computer history feature for their desktop app. It remembers user activity across different apps and websites on your local machine.
Mechanically, this solves the exact data silo problem, but at the individual level. Before this, a chatbot was an amnesiac. Every time you open a new window, it forgot you.
But with persistent local context, it observes your workflow. It sees you opened a PDF, copied a line to an email, checked your calendar. It has a persistent memory of your digital life.
And tools are evolving to utilize that in real time. Look at Grokbot. You can now run multiple agents simultaneously in the same workspace using simple app mentions, like tagging a coworker in Slack.
So you can have an @inbox manager cleaning your email, an @calendar bot prepping meetings, and an @chief-of-staff bot whose only job is to talk to the other two, synthesize findings, and write a daily briefing for you.
It's the beginning of multi-agent communication. You're managing a swarm of digital employees.
Which brings us to the grand finale of our sources today. This concept of agent swarms multiple models communicating, debating, and iterating just redefined what human capability looks like.
This story gave me absolute chills.
Same. There is a deeply complex matrix math problem called Cruz's Conjecture. It deals with the upper bounds of polynomial operators applied to matrices.
It is incredibly dense mathematics.
It has been completely unsolved for 22 years. Top mathematicians have battered themselves against this since 2004, and it was just solved.
But not by an MIT professor?
No. It was solved by Dr. Shanmu Jin, a neurosurgery resident in Beijing. His background is in geology and medical training. He just encountered the problem tangentially while researching brain ultrasound tech and taught himself advanced math to understand it.
It raises a profound question about the democratization of genius. He didn't solve it with a pencil and paper.
No, he used GPT 5.6 Sol, and the way he used it is revolutionary. He took the model offline and ran a 16-hour autonomous compute session.
Let's break down the mechanics of a 16-hour compute session, because he didn't just type solve this conjecture and wait.
Right, the answer didn't exist in human history for the AI to look up.
Exactly. The AI had to generate novel mathematical reasoning. Dr. Jin essentially built a debate chamber, a swarm of sub-agents.
How does that work?
He instructed Agent A to propose a proof strategy based on matrix algebra axioms. He instructed Agent B to aggressively look for logical holes in Agent A's proposal.
Okay, so it's fighting itself.
Yes. And Agent C's job was to attempt to optimize and simplify the equations. He forced these agents to argue with each other, testing proofs, finding fatal flaws, refining logic over and over autonomously for 16 solid hours.
And the proof they finally produced, Dr. Jin submitted it, and it was rigorously verified by top mathematicians at Cornell. It's real, the math is flawless, a 22-year-old conjecture is solved.
The paradigm shift here cannot be overstated. The AI generated a novel, previously unknown truth about the universe. But the crucial insight is the changing role of the human.
Because Dr. Jin didn't do the calculation.
Right. He architected the swarm, directed the agents, and then verified the output.
So what does this mean for you, the listener? If a neurosurgery resident can use an AI swarm to solve a multi-decade math puzzle, the rigid barriers between specialized fields are completely dissolving.
You no longer need a PhD in a specific discipline to make a massive breakthrough in it.
The barrier to entry just went from 20 years of specialized study to having a good idea and knowing how to architect a swarm.
We are entering an era where the skill of generating work-writing code, drafting a brief, calculating a proof is becoming fundamentally commoditized. AI can generate raw work endlessly and cheaply.
But the skill of verifying complex work.
Yes. Knowing what specific questions to ask the swarm, recognizing when the output is actually correct, and understanding why the answer matters. That human skill is becoming incredibly scarce and infinitely valuable.
Okay, we have covered massive ground today. We started with the tens of billions pouring into infrastructure, the power grids, and the Tinkerbell problem of market belief.
We unpacked the open weight challenge from Chinese labs, model distillation, and the enterprise dilemma of cost versus trust.
We waded through the messy reality of data silos, the very real danger of zombie agents, and the rising cyber stakes with zero-day exploits and vishing.
We gave you a weekend workflow for local agents, and we debated Dario Amade's timeline for winning back public trust.
And we finished with Dr. Jin and the incredible democratization of genius-level problem-solving. It is a landscape defined by extreme friction and extreme potential.
But the story of Dr. Jen leaves us with a profound final thought for everyone listening.
What's that?
Think about your kids or your own career. If generating solutions is now cheap and easy, and verifying them is the new premium human skill, what happens to our education systems? Are we still spending all our time and money training students to write the 5-paragraph essay and solve the road equation?
Wow.
Because if we are, we're training them for a world that no longer exists. Do we need to radically pivot right now and start training humans to be the editors, the curators, and the directors of an alien intelligence?
That is the exact question we all need to be asking ourselves on Monday morning. Thank you so much for joining us on this deep dive. The ground beneath us is shifting incredibly fast, so keep your eyes open, keep questioning the rapid changes around you, and we will catch you next time as we continue to unpack the future.